Welcome to today's session. This is a talk about Project Amber. This is a project in Java. How many of you know the meaning of the word Amber? And give me your definitions of the word Amber. Anyone? It's a stone. It's a fossilized stone, yes. Anyone? Any other definitions of the word Amber? Insects are trapped. It's a fossilizing agent. Why was this project named Amber? Can anyone hazard a guess? Choose. Be creative. Why would a technology project be named Project Amber? Isn't that the anti-pattern of everything you can think of? Because amber is a fossil. Why would you want to go back in time? Why did they do this? Okay, unpack potential. Great. I'm not going to keep asking you to guess. I'm just going to share this right now. The name Amber has two meanings, and I know the font is deliberately small because I did not want people to guess it, and I want people to come forward and huddle together. So Amber stands for, the Greek equivalent of amber is electron, which actually means a beaming sun. So it's actually a very positive message by itself, but that's not the real purpose of why it was named this. Amber is a lot about pattern matching, and we'll talk a lot about pattern matching today. And this was inspired by a book named Amber by an author named Zelensky, in which a common theme is walking the pattern. And that's what we'll take a look at today, how much pattern matching actually impacts the developers and improves their productivity. We'll take a few examples as well. So this is going to be part theory and part code. So we'll do both, and we'll do a little bit of a walkthrough of what the theory looks like. We'll go into code, we'll run some examples. I get to embarrass myself in front of you when this fails, and this is how we're going to do things. All right, so the first thing we'll take a look at is Project Amber delivered on a lot of features, and I just wanted to give you a quick walkthrough of how my presentation goes through. I don't use PowerPoint, I don't use Keynote, I use IntelliJ IDEA. That's where my presentation is coming from, and this code is available on GitHub, should you want to refer to it. At the bottom of my screen, you will notice a green text, that's where the URL is. And the slides will be shared, and I will also put in a QR code at the end of this presentation that you can actually snap a picture of and go to this website. Now, Project Amber delivered on a few features already. There are a few features that are currently work in progress, and there are some that are on hold and some that are in a draft stage. We have not yet been completely sort of formulated, and we're going to take a look at a few of these. The delivered features are awesome. They're very useful already. And this entire presentation as of today is based on Java 18, which was recently released. So that's mentioned in the text above. It's almost like my caveat, your mileage may vary kind of a message. So this gets updated on every single Java release. There are more new features that get added, and I change my presentation accordingly. So first, we'll take a look at local variable type inference, which was one of the coolest features added to Java. And this was added through a JEP. A JEP is a Java enhancement proposal, in case you did not know that. Any change that comes into Java has to go through a JEP process, which is then voted upon, agreed upon, and a target JDK version is established for that. This JEP was delivered in Java 10, and vars were introduced into Java. A var allows you to shorten your, I guess, declaration and assignment into something more meaningful and readable because the name is pretty obvious for you. So we have a var list here that creates an array list. We have a var stream that creates a list to stream, etc. There are some incorrect usage patterns as well. You cannot declare a var without a value. That is something very useful to know. This is a compiler error. You cannot create some ambiguity when you create a var. For example, line number 2 on the second code extract, you will notice, is a var f that tries to create an anonymous body which does not have a type that's easily inferable. That's not allowed. You cannot create null vars. So you actually get rid of null pointer exceptions when you use vars, which is amazing. And also, you can't create, let us say, ambiguous array types. For example, on the 4th line in the second code segment, you notice that I create a var k, and it has two values, 1 and 2. Is this an integer? Is this a long? There is ambiguity here, and that's not allowed when you do a var. These are some gotchas that you should be aware of, and these are very helpful gotchas because they actually prevent you from making obvious mistakes when you use vars. That's something useful to know. But this wasn't in itself very useful. So vars were great, but there were some features missing which were later introduced where you had local variable syntax for lambda parameters, where you could actually specify, let us say, along with a var, you could add more, I guess, annotations on top of it. In this example, if you notice in the code segment, you can create a var x and a var y to be used in a lambda, which was not possible when JDK 10 was released. So Java 11 or JDK 11 fixed that, and you get the ability to use vars and lambdas. You could also use annotations on top of this, and this was one of the most beneficial use cases of where you would use, let us say, a var within a lambda. In a regular lambda, you could just have declared an x and a y in the first code line. I could have just said x comma y, x dot process y would have been a very valid syntax. But why do I need a var at all in this place? Is when I actually have to annotate the vars with, let's say, some attribute which is not possible to be annotated otherwise. So if I just did x comma y, I would not be able to annotate them. So I actually, by using the word var, I'm allowed to now add more annotations to it. And that's a very useful feature for that was introduced in Java 11. The next one we will look at, and this is where I'm going to actually, yes, please. They're not part of Java. No, they're just random annotations that I added in. You can add your own custom annotations, and those are completely valid. And yes, I deliberately included 2 annotations that are not a part of Java. So switch expressions is the next concept that I will take a look at. This was delivered over a multiple phase mechanism. This is something I want to introduce to you now, is that starting Java 11, every single new feature that gets added into Java has gone through what is known as previews. So there's a preview that happens at least 2 or 3 times, and once people are in agreement with how this functionality works, it can become a full-fledged release. So a JEP 325 in Java 12 introduced switch expressions. We'll get into that in a minute, but switch expressions were introduced in Java 12. They were further refined in Java 13 through JEP 354. And then finally, JEP 361 was created where they finalized switch expressions in Java. You'll notice in the first example, I can use an arrow-based syntax. So it's an expression-based syntax that you could use with switch expressions. So you could actually simply, without using a break statement, without using some sort of a return statement, evaluate an expression using an arrow syntax. And that is super awesome and super convenient to use. In the second code segment you see below, I create an int quarter. So I'm using an expression here to switch on a month, and based upon the month's value, I'm able to return something back. I do not use break statements here. And since I use an enum, I don't even need what is known as a default. We'll talk about that later, but notice that a switch expression is complete in itself without the use of a default. It's exhaustive. And please keep that in mind because we're going to come back to an enhancement that came in later that benefits this as well. You'll notice in the second case, in the second example, starting line number 9, there's an even or odd based upon the month's value, and you can actually do more evaluations on, let us say, the enums, and based upon values, you can either choose, the case default, a case that has some content, or a default value. So the defaults are still possible. However, you can also have exhaustive switch cases. That's something that switch expressions have introduced recently, and that's super cool. So you can use either an arrow-based syntax, which allows you to sort of immediately return a value, or you could use a yield-based syntax, which is almost an equivalent of that, except it can, it's more verbose, and it allows you to sort of create multi-line segments. An arrow-based syntax would need complex structures, you have to use curly braces, etc. What we can do is now take a look at the code demo itself and see if this works. We have a month December, we have a December quarter, and based upon the quarters, we are determining which quarter it is, and we print out the quarter number. And then the same with the yield functions. You could use even or odd, and based upon the month's, I guess, numeric value, either declare it as an even or an odd value. So let's run this real quick, and this is my first chance at embarrassing myself if this code fails to work. Looks like I did not, but December is Q4, and January is an odd month, is what got printed out because we did this. Now, you can further experiment with switch expressions, but I'm going to let you do that later. I'm going to go back into my code segment. So that was switch expressions. Another cool feature that Amber added is text blocks. I don't know how many of you use text blocks but this is a super awesome feature where you can have multi-line text in Java now, declare it and use it in the indented format that it is intended to use. And here's an example you can see on, I guess, the code block section that's marked in light red. You have the lorem ipsum text with indentation, and this will print out exactly as it looks like. There are a set of rules on how you can use text blocks in Java. Amazing guide that was written by, I guess, Stuart Marks and Brian Getz together. And this is something I highly recommend you take a read at. It's got a lot of details on what you can and cannot do, what you can expect and cannot expect when you use text blocks. Something to look at. It's worth taking a look. This JEP was originally proposed as raw string literals. That came out in, I guess, Java 12, JEP 326, which was then sort of removed and replaced with a new JEP for text blocks that came out as JEP 355 in Java 13. And for the, after a few iterations, going through some previews, it became a final feature in Java 15. So starting Java 15, you have text blocks that you can use. Quick code walkthrough of how this looks like. And there are a few examples here that I would like you to focus on. You could do single line text, it's easy. This will throw an error if I were to uncomment this line, and I'll explain why in a minute. When you create an intentional multi-line text and you put it all on one line, the JDK compiler will actually complain, you're just creating a string. Why are you trying to do a multi-line text with that? So let's try this real quick. If I were to do that, I immediately get an error that says illegal text block start, missing a new line character, which is an amazing, I guess, hint that you should not be using multi-line text when you have a single line. So I'm going to comment this back. Commented the wrong line, pardon me. All right, great. So let's take a look at a few more examples. I have text 1, where I have indented text that is in one single format, where my multi-line text begins on one line. These are the three double quotes that I put that indicate that I'm starting a text block. And then I start my text right below that, and I have my ending three double quotes in the same indented column as my text started with. The second example, I have a double-quoted text, and I am missing the slash characters at the end of it, which means I am deliberately telling the Java compiler that these are separate lines. In this case, I'm telling the Java compiler that I have exactly one line. I am breaking it intentionally into multiple lines just for readability. And the second case, I don't do that. That's the difference. And the third example you'll notice is that I have my indentations tabbed in by about 8 spaces. So let's take a look at how these print out so we can understand how text blocks work. Real quick, if I were to run this example, here are the outputs. In the first example, as was correctly indicated because we used a slash saying, I am just doing this for readability, not for printing it out this way, and I use slashes, it all printed on a word wrap text. If I were to remove my word wrapping, this particular line would be on one single line. And that's possible because it did not actually convert it into indented lines of text. The second example you can notice begins at the 0th column of output and just prints it according to how I sort of laid it out when I created that string. So I have lorem ipsum going up to adipessing, and elit starts on a new line. And this is exactly how it prints out. It does not indent all these additional spaces that I have because my double quotes, my three double quotes start immediately after where my first line begins. So there's no indentation rules that I have specified here, and therefore it takes the exact string, starts it from the 0th column, and prints it out. The third example, I have 7-space indentation. So I actually deliberately put 7 spaces after declaring the lorem ipsum. Now, when I run this code, you notice that I get 7 indentations on the output as well. But the rest of the lines follow suit, and they also have the 7 indentations. So this is how Java can actually determine what indentation model you want to follow and what is actually your desired outcome and deliver that for you. So these are things that are useful to know. This is not something that you would, in your day-to-day practice, just use because sometimes you just write some code or you copy-paste from elsewhere and you wanted it printed exactly the way it should look like. And this will deliver that for you. Great. Any questions about text blocks so far? Yes, please.
The new lines are being inserted by the compiler. Is the new line a carriage return, a line feed, or a carriage return followed by a line feed? And can we control what type of line feed
Yeah.
is being put in?
So Java usually does a CRLF. So it should be honored on Windows as well, but the Unix and the Mac will definitely use a CRLF. So it does get a new line in, no matter which way. It's operating system neutral, which is the benefit of using Java, of course, but it will appear the same way on every single operating system.
And it'll always be CRLF, no matter.
1013.
Is there a setting that we can put in the compiler and say, we only want line feed, or we only want return? So we can adjust it for whatever environment we're in.
You could. I mean, it's after all a character, so you could do a char 10 or a char 13 and get that. I don't see the value of doing it. It is possible, I guess. I mean, it's the same thing we can do with, let us say, a regular string on one line. I don't see the immediate benefit of doing that, but yes, I believe it is possible. I mean, you could use a /t/n within your string. Correct. But that's a great question. Awesome. So that was text blocks. Any other questions before I move on? Yes, please. Yep. Okay, so correct. So right after where the string declaration begins, all I have to do is this, for example, right? You notice where my text started, you see that little line that my IDE is indicating. So now if I were to run this code, let's take a look at what happens. You notice that one single space that came in, and that's the hint the compiler is getting that there is a line that I'm off by. And Java's able to recognize where your string starts and how much you're indenting from the start of the string. That's super cool.
Is it better using spaces or tabs before the
Let's try it. You know, I'm here to be embarrassed, so let's do this. Let's try that out. So I have spaces. I use spaces. I don't know if my IDE works with tabs. I'm going to try.
I meant to the left of the last one. If you, like before that line, there's tabs before the line.
You're talking about this?
Yeah, there's tabs in there.
It shouldn't matter. It shouldn't matter. As a general default, I guess I'm going to annoy half of the crowd here. Don't use tabs. All right. If some people start walking out because I said this, my apologies. But all right. So great. Thank you. These are amazing questions. I appreciate this. So going back to text blocks, that was text blocks. Text blocks are pretty interesting a feature, and I highly recommend you experiment with those. There are some rules. There's a lot of documentation available. Please do go through this documentation and enjoy text blocks. I actually love this feature. They're very useful when you're trying to print out outputs, let's say in unit tests, etc. So that's a big plus. One of the most amazing features that Java added through a couple of JEPs, I mean, it started in Java 14 and is finally delivered in Java 16, is pattern matching. Pattern matching, in case you're not aware of me, as something I am very passionate about, and I think all of you should be passionate about. It introduces the concept of flow scope variables, and I'll explain flow scope variables in a minute. But I don't know why I got MS Outlook showing up. Okay, it adds what is known as a pattern for the instance of. And let's take a look at what that means for us. In the past, when we had an instance of check, we would take an object, do an instance of check on the object, and we would basically pass in the type and expect something to happen in the conditional block. The first thing we would do is do a cast in the conditional block and try to convert that object into something meaningful for us and use it. With pattern matching instance of, you actually now can inline your variable along with the check itself, which makes it far more simpler. And this is flow scoped. Remember this term flow scope because we will come back to that as well. So flow scoping would mean my scope is visible within this particular conditional block and is not visible in the next conditional block or the else conditional block. And that's super useful. Now, just theory is not going to help us. Here is another chance for me to embarrass myself. Okay, so here I have a long, it's a 7 long, and I'm just using this print if long method here. And the second case, I have a null long, and I do a print if long, null long. Let us see what happens in this case. But before we actually run this code, here are some things, some jargon that I would like you to know. The object in this case, the object is a variable. That's a jargon you use. And then the instance of long, my long, is what is known as pattern matching. And that's what we're doing, pattern matching for instance of, right? Within that instance of long, my long, the instance of long is the predicate. It is the conditional check. So it's usually known as the test in the Java jargon, but it is a predicate in normal developer jargon. The my long is considered a target by the Java jargon and also known as the binding variable among us developers commonly, not just Java developers. So either terms you use, there's a test in a target that is embedded into one single expression using pattern matching for instance of. And it is amazing. So let's take a look. I am assuming my output would be a long followed by number 7 and a message that says not an instance of long. So let's see if that is true real quick. Let's run this example. And sure enough, I do print exactly that, a long followed by 7 and not an instance of long because I passed it a null, which is ambiguous and not a long, right? And this is something that I wanted to share with you. Although I declare it as a long, since it's passed in as a null, the pattern matching instance of will fail. Yes, please.
I have one question. I've read the term pattern variable and binding variable. Is that the same thing?
There are different. So the question is a pattern variable the same as binding variable? The answer is there are a lot of different names that people throw around, which is why I'm actually emphasizing on the fact that please stick to target and binding variable as the names. A target or a binding variable is the variable that you create when you match the predicate. So it's either a test or a predicate and then a target or a binding variable. That terminology helps because that's commonly shared and everybody understands that. Anything else you use is an inference, right? And we prefer not to have inferences in this case. Any other questions before I move on? Let me go back to the code. Let me go back to the code so you can ask. Yes, please. Line 14. You want me to make this a var? Like that? The reason it will not work is because there is ambiguity about the object. It could be null. And as the rules for var say, you can't use nulls.
Where you say object consists of long, my long, which you require in order to execute that value of my long, you say the number 10.
Okay, so the question is, not only that on line 16 I have object instance of long, my long, can I also further guard it to include a predicate of some value? Unless that is met, I'm not entering the condition. Great question. 2 more minutes, I will get there. Okay. Excellent question. You had a question, sir? Yes. Okay, so I'm sure you've not seen my other talk on algebraic in Java, but I will share this with you. Everything in life is about patterns. We live by patterns. In fact, everything we do, we learn by patterns, we assume by patterns. So how do you determine that something is of a certain type? how do you make that? How do you determine that this chair is a metallic chair, right? You sense a pattern. You see something shiny. You see it's moldable, it's malleable, and then you have made a pattern that this has to be metal, right? So, for example, anything you take, you assume based upon certain patterns that you've already seen in the past. Same thing with Java. When you have an instance object, you are looking at a pattern of an object and therefore making an assumption that this object is of that pattern. Hence the name.
Recently at this talk, I heard it referred to as smart casting, which I don't know, I find that more natural than pattern matching, because I always think of regex and pattern matching.
Great. So the suggestion or recommendation is to call it smart casting instead of pattern matching. Great, but I'm going to show you further examples where pattern matching is justified. So let's do that. Great. So we were on pattern matching for instance of, which is an amazing feature, and I love it. I recommend you use it. The next Amber feature that was delivered is records. Records are amazing. How many of you use Lombok? Why do you use Lombok? Okay. The most important concerns for a Java developer is that it is too verbose for me to create accessors, mutators, constructors, toStrings, equals, etc. So Lombok is my solution, which is awesome. However, now Java has a feature known as records. I don't know how many of you use records, but if you've not, please do check it out. Records are amazing. They are immutable objects that provide you automatic constructors, automatic getters, no setters, because they're immutable, of course, right? There's a small gotcha in that the getters don't have a get prefix. That is something you need to be aware of. So it is exactly the name of the variable followed by two simple braces is how you access a variable from a record. There is no setter, of course, but you can override constructors, and I'm actually going to show you a very lengthy piece of code for this. I'll have a lot of opportunity to embarrass myself in this case. All right, great. So first things, it's immutable. It has built-in constructors and accessors, no mutators, of course, and there's a JLS for this, the Java language specification, which has a thorough and immense amount of detail that I would like you to go through. I just put one small example here where you can create a one-line record. In this case, line number 1, the record point, actually created a point object for me. So in the past, we used to create tuples or tuples. I don't know, some people got tuples, some people got tuples. We've done those. We actually created, I guess, pojos that were just holder objects that we never wanted to change. And all that can be replaced by us using records now. Records are amazing. Here's an example of a record where I have a color, which is a Java object, of course, and I have an int x and an int y, and I am creating a constructor. Notice something odd about this constructor is that it does not have the parentheses. It has no color x or y arguments being passed to it. And this is a new constructor. It's called a compact constructor, which records introduces. We'll take a look at it in code as well. I just wanted to highlight that there's some super cool features that records introduce. This is one of them. In this case, if the color is not null, I'm printing out the color, else I'm throwing an exception. And records allow me to throw an exception on construction and not create the record for me. So my checks are much more ahead of what would normally be a validation routine. I can immediately stop a record from being created because I can validate through a constructor, and we'll take a look at this in an example. Any questions before we go into the code? Great. So let's take a quick walkthrough of this entire code. There's a lot going on with records that I would like to share with you. Here's a simple record I created. It's a one-liner. It has a string value and an integer value. Now, another way of looking at records, I was talking about compact constructors, is I can create a record with a compact constructor validation. Here you go. Let's take a quick look. So there is a no argument constructor that I have, which means I don't have to pass in the string value or the integer value, and I can check and validate while I construct my record that they're both not null. And should any of these be null, it would throw the appropriate exception. In this case, it does throw a null pointer exception, if I'm not mistaken. But you can validate your record before you create it, which is awesome. I'm going to minimize this, and I'm going to show you a record with a compact constructor that throws an exception in this case. So I have a constructor, and if the integer value happens to be below 0, I choose to actually throw a custom exception that I created right below it. I created a runtime exception, and I'm able to invoke it, and I can throw that if an integer value less than 0 is passed into my record. So you get some validation techniques that were probably not so possible in the past with classes, or you had to go through multiple steps in order to get there. You can create a record with multiple constructors, which is not something a lot of people normally do, but it is possible. There's a small gotcha though, in that your ultimate call should always be to this. You have to always call it this. That's the only way you can't have multiple bodies for your constructors. So every constructor at the end has to call the compact or the full constructor. That is a must, because it's I guess more uniformity in its structure than we had in the past with classes. So you don't have as much of a free-form construction style as classes do, and this is with deliberate intent. So please be aware of that. And every constructor finally has to call the full constructor is what I'm trying to get at. You can also extend records from interfaces, which is not something most people normally do. I guess I'm a bit more weird, and I tried this out, and it works. So you can create an interface, and your record can actually extend and implement an interface. A record by default is immutable, so please do remember that. Here's an example where I have a describable interface that I am sort of implementing and overriding within my record. So you can have method bodies that don't belong to a record within a record. That's super cool to know. You have a way in which you can do this. It's not just your, I guess, accessors, but you can also add some amount of behavior in your record. And you can add behavior that's conforming to an interface, is something I'm showing here. Also, another cool thing, we've not yet talked about sealed classes. We will get to that in a minute. But sealed classes allow for an extension for records, because a record is final and immutable by default. So you don't have any way of extending a record. You don't have any way of modifying a record. So a sealed class actually permits a record by default. And it's super cool to know. And of course, I basically run these as examples. So everything that we just walked through is just being, I guess, created and run here. Just a quick, I guess, let me just run this code real quick to show you some examples of what I'm talking about. So here we go. I'm going to quickly talk about the simple record. We created a record with a string and integer value. I don't think I need to explain that a lot. But then we also created a single argument constructor like so, where accessors don't have a prefix. So we simply do a string value instead of get string value. That is something I talked about earlier. And we talked about compact canonical constructors, where I don't pass in any kind of parentheses or arguments, but it expects all the arguments in there. We did that. We created a string value of s and an integer value of -3. And it prints that out. You notice that it created a valid record with string value of s and an integer value of -3. We then create a compact canonical constructor that we use for validation. The validation we used was that we wanted something not null, and the string here is set to null, and therefore it created what's called an invalid record, which threw a null pointer exception. We use objects.require not null in the code. And then we used an exception-based validation, where we said we will throw a custom exception because it did not match, let's say, the integer being a positive value for us. In this case, we set an integer value of -3, and we throw our custom exception, which we catch, and we print out the value. And you will notice that number 5 says record creation throws an exception. So we were able to prove that you can not only validate, but you can also throw custom exceptions. Not just Java regular exceptions, you can create your own exceptions as well. Next, we'll take a look at a few things that were possible. I mean, we talked about multiple constructors and records. I don't know how much time we've left, unfortunately. So, all right, I think we have a very few minutes left, so I'm going to rush through this real quick. We did some constructors, we did some interface implementations, and we did some accessors. I have time? I'm sorry? 5 minutes? Okay. 20 minutes, okay, good, good. I do need 20 minutes. So we did some interoperability with seal types. We noticed that a seal type can actually permit records because they are immutable and final. So you can actually permit records as an extension of seal classes. One cool thing that was recently added in Java from Java 15 is local records. So on the fly, you can generate records. And this is very useful when you're in a for loop, for example, and you want to suddenly use a tuple of some I guess, complex object, but you only need parts of it. You don't need the complete object. And you can, on the fly, create a record using what is called a local record. So I can declare a record within a class. This is new. This was introduced in Java 15, and it's super cool. So here, I just created, I guess, apples and bananas with some values, and I can use it immediately. Right? So this is a cool feature. A lot of people have not used it in the past. Now, for the gentleman's question about why is this not called smart casting? I think Scott was asking the question earlier or suggesting. This is where pattern matching excels, right? Here I have a class.isRecord, and it returns whether a class is a record. That's a pattern match. And you can use an instance of check for records. You can do instance of record. And you can also do an is assignable from. That's another pattern that most people are not familiar with. A dot class or the class object in Java actually has an is assignable from method. And in this case, I could do record.class. A record is actually a class. A lot of people don't know this. Is assignable from a simple record. And you get the value as yes. And of course, you can always do pattern matching on records themselves. You could do an instance of record, a record, and get the value outputted. One cool feature, how many of you know that similar to an is record, there is an is enum for enums? Are you aware of that? Are you aware of the gotcha in that? In that if your enum has a body, why does the is enum fail? Anybody? It actually converts it into a class. It does. That's super cool. Anyways, trivia, we'll come back to that. The next thing we'll take a look at is sealed classes. Sealed classes are amazing. Sealed classes can limit or determine which further types can be extended from it. You have controlled extensions. One of the biggest drawbacks of using, I guess, inheritance models in Java in the past was you either had what was known as an open class, which was fully open, you can extend it any number of times, or a final class, which is so closed you can't do anything with it. Now, Seal provides you some flexibility in between where you can deterministically evaluate which classes you can extend and what you don't permit going forward. So sealed is a closed or a limited hierarchy that you are establishing. Now, there is some amount of, I guess, challenge and confusion when you look at sealed classes. It's just like, hey, but someone else is determining what I can extend. I'm not doing that. There are some things we will talk about which will show you how you can get away with this. There are some flexibilities in sealed classes we'll take a look at. And I have a lot of opportunity to embarrass myself while I do that because I have not written this code before. So we're going to do it live. You have new modifiers such as sealed and non-sealed. These are new modifiers added for classes. It requires a new permits clause with your sealed classes. And here's a small example. You have a sealed class, a sealed abstract class in this case, called mySealed, that permits extension 1, extension 2, and extension 3. So I can create a sealed class from a sealed class, that is extension 1, and that permits, let us say, extension 1_1 and 1_2. I can create a final extension from a sealed class. I can non-seal from a sealed class. These are three options in menus where I either have another sealed hierarchy, I have a final class, or I have an reopening of the sealed class. Why is this useful? So I have some core, I guess, construct that I want, I guess, my subclasses, my immediate subclasses to share. And beyond that, I am ready to open up for other classes is when you would use a non-sealed class. And we'll take a look at an example, but if anyone has questions, we will run this code together. So very quick. Here is an example where I have a final class, I have an abstract shape, and I extend a pentagon from that. I have a custom shape, and I extend a hexagon from that. and I have a shape object, a shape class of which I have a final circle, I have a triangle, and that itself is another sealed class, and then I have an unsealed or a non-sealed class known as four-sided shape from which I extend like rectangle and square. So very quick walkthrough, I have a non-extension shape which is a final class, therefore you cannot extend anything here. I have an abstract shape which is an open class, therefore anything can be sort of extended from this abstract shape. So I extended a pentagon, and then I have a class that has no, I guess, modifiers associated with it, a custom shape, which means I can extend a custom shape. In this case, I extended a hexagon from that. Now here's our sealed hierarchy, where I have a sealed abstract class named shape, and it only permits a circle, a triangle, and a four-sided shape. So it has some methods in it, and this is the behavior that I want pushed forward into my immediate subtypes. Great. I also have an octagon. This is sort of commented out, but this octagon tries to extend shape. And when I uncomment this line of code, you will notice it immediately fails. And it fails with a message saying octagon is not allowed in this sealed hierarchy, which is how you are limiting your hierarchy through sealed classes. And that's a very useful feature. You have controlled what can extend and what cannot extend your shape. Great, so I'm gonna comment that back. And then we had circle, triangle, and four-sided shape. Here's a circle, it's a final class. Oh, so one of the extensions of a sealed type could be final. Another is another sealed hierarchy. We talked about this where a sealed type can further extend into another sealed hierarchy, and that's acceptable. So in this case, a sealed triangle extends shape because it's permitted, and further permits an equilateral triangle, an isosceles triangle, and a scalene triangle. That's possible. They're all triangles, which is nice, and they're all final classes in my example. I didn't want to further complicate it. However, I can also create what's known as a non-sealed class, which is what is the example shown on line 183, where I non-seal or unseal a class and therefore reopen it for further hierarchies without any restrictions. So everything is possible with sealed classes. A cool feature of sealed classes is I can actually get away from all of the permits that I put here. Let me go back to my code. You see these permits? I can actually get rid of this code if all my classes are declared in the same Java file. So if I were to delete this, my code would still work. But the one thing that would happen is my octagon class would also now work. Because it is on the same file, it's on, of course, forget the fact that it fails the constructor, but you notice that my shape extension is now possible. This is super cool. So you can actually declare all your extensions in one single hierarchy in a sealed, sealed intent without having to use a permits. And when you extend further, when you want to sort of grow your hierarchy, all you do is add another class in the same Java class, and you're all set. So it's kind of cool. It's a nifty feature. It's something most people are not aware of. So check it out. And I'm going to take a quick break and ask if there are any questions at this point. Correct. The question is the octagon class a regular class? And the answer is yes. The mere fact that I got rid of the permits clause, however, it all is coded in one single Java file, the .java file, implies that they are an extension of the sealed class, allowed extensions of the sealed class. It will become a non-sealed class by default. Correct. Correct. If it is visible, because this is inside a Java class file, and this is a non-public class. It's package protected, yes. So within the same package, yes, but outside, no. Let's try it out. You can't make it public within this Java file because you can only have one public class for Java file, right? So, cool, but great question. Awesome. So going back, I think I have a few more slides, so I'm gonna rush through this. Okay, the next thing that we want to talk about is record patterns. These are amazing. We've already seen pattern matching across, let's say, objects, But record patterns introduces something super cool, super cool. And I was just having a conversation with some of the people who actually are the JDK developers, and there is a lot more that's coming out soon. I'm excited, so should you. Here is an example where I have a record, point int x and int y. And one of the coolest pattern matching aha moments for me was when I saw this line number 4, O instance of point int x comma int y. And I'm now directly able to use x and y out of it. This is awesome. I actually have deconstructed my record on the fly, and I'm able to use the values from that record. And it's not just a record. You could use a regular object soon as well. You could use, let's go into more complex examples, so I don't want to get too excited at this point. I have a record point of int x and y. I have an enum that has, let's say, all of you are familiar with color. I have a color enum, red, green, blue. I have a colored point, which is using both a point and a color. So it's a more complex record. And I have a rectangle which uses 2 coordinates for the colored points. I don't know why you want a colored point coordinate, but you have a colored point upper left and a colored point lower right as your rectangle's 2 endpoints. And in this example of pattern matching, I have a rectangle object being passed to me. And if R is an instance of rectangle, I know it is a rectangle because that's what was passed. If R is an instance of rectangle, and within that, I am actually deconstructing a colored point, from which I'm deconstructing a point, and I'm getting the coordinates x and y, and I'm also getting the color, right? And then I'm getting the left, the lower right corner coordinate as is, because I don't care so much about it. I actually am able to use all the deconstructed values right away. And this is so nice because I can guarantee something is that no matter what, if any of these are null, it would not enter this loop. I would never get a null pointer exception. It is automatically protected. This is awesome.
It's interesting to see that you can use bar here. You don't have to type in everything.
You don't have to type in everything.
Out of curiosity, are the types are fixed though? Like if you had flipped like if it was in string, you would flip straight in when you compile, right?
It wouldn't compile. Now, I guess the signature and the arity have to match. That's for sure, because that's how I guess it would work. Unless you actually create 2 functions or methods that have that alternating signature, in which case you are allowed to do things like that. The ambiguity checks that Java uses for its method calls stay the same with records. Any other questions before we move further? Okay, so you want to check if there is a guarding, and that was a question from the gentleman earlier. We're going to get to that in a minute. But yes, you do have some flexibility where you can guard. And the guarded patterns currently use what is known as an ampersand technique. So you have an instance of, and then you can do a double ampersand, and then you can pass in what is known as your guarded pattern. Hopefully, I'll get to that in the next slide. But yes, let's hold on to that thought. Here you go. This will probably help a bit. So you have pattern matching for switch that was introduced recently in Java. It started with Java 17. It is still a preview in Java 18, so it's not yet delivered, but you can enable preview and start using it right now. Don't put it in your production code yet because it's undergoing a little bit of change. There's a new JEP out for it. I'll talk about in a minute. But here I have a record point. I have an enum color. I have a sealed interface. It's possible. S that permits A, B, and C. I have, I guess, A, B, and C implemented as final classes and a record. So simple stuff we've already talked about before. But here is the amazing pattern matching techniques that I want to talk to you about. I have a switch O, and I handle a case now, because if you don't handle a case now, you're going to get a null pointer exception with switches. All of you should be aware of that. Now, case integer I, double ampersand, guarded pattern of I less than 50. Flow scopes to this particular expression, simple or complex. Same variable being used on the next line, case integer I, for all values that are greater than 50 will pass the third line. Line number 12 will be used instead. This is how you can guard patterns with, I guess, switch case statements. And this is super awesome.
Order matters, right?
Order matters. Or, yes, please.
Instead of using the hard code value 50, could that 50 be a variable of type int that is available, within the scope of that switch statement?
I would, yeah. So you can't have a variable available within the scope of a switch statement, because the switch statement begins with this curly brace, ends here. There is no place to declare something within. However, use a constant.
Okay, but what if you had it on line 8, you've got static void type tester object code,
Yep.
and then how about if you inserted a line between 8 and 9, and you said int something equals 25?
I have not tried that out.
With the switch statement, and you reference that variable, you just click.
I have not tried that out, but an effectively final value should be allowed. I have not tried it out. That said, as long as you put an effectively final value, I don't see a problem. If it's reassignable, I don't know how that will work. I did not experiment on that yet, but that's a great question. Something we can sort of experiment later. Yeah, awesome, awesome. All right, so let me just take a quick look at the time. Was there another question? Yes, please.
I believe you can't mix the primitive case tables in with this case tables.
Yeah, because we passed in an object.
Yeah, you'll always use the object reference
Correct.
array, right?
Correct. And we do. We actually have integer arrays, which are objects that you can actually pattern match against. So this is again amazing. And you've noticed that I have seal types, and there's a default. Now, JEP 420 is interesting because, and by the way, these are hyperlinks, so you can actually click on them. They take you to the JEPs. When you get my presentation material, you can actually feel free to click the links. They're all link-worthy and accessible. Now, JEP 420 introduced what is known as an exhaustiveness model. So, for example, when you do a switch case on an enum, you never put a case default. Why? Because you know exactly all the values of an enum. You don't have to do a default on it, right? Similarly, with switch case statements for sealed classes, you know exactly all the inheritance of the sealed class, so you can skip the default, right? You know exactly what happens to the sealed class, how many extensions it has, and therefore you can make it automatically exhaustible. You can also do dominance checks, which was the question Scott was asking earlier. A dominance check is basically your, I guess, sequence in which you're doing your expressions and guarded expressions. So if I were to, let us say, flip line number 11 and 12, the compiler will actually throw an error. And that is your dominance check. Because integer I supersedes integer I with I less than 50. So the ordering matters, and the dominance checks take care of that. That is JEP 420. Anyways, awesome question. Thank you for that, Scott. Yes, please.
How is null being handled here? Like on line number 10, you've got a case null. What if that line was not there? Would you fall through to the default case or not?
No. So for a brief period of time, it would have gone to default, but it is back to the normal expected behavior of throwing a null pointer exception. So before all this, if you were using, let us say, Java 8, and you had a switch that accepted a null value, you would get a null pointer exception. Midway, it went to default for about 2 or 3 releases, and now it's back to being a null pointer exception. So it changed for a brief moment, and then expected behavior was brought back. Great question, though. Any other questions? Awesome, awesome. I love this interaction. Thank you so much for that. Lambda leftovers, amazing new feature, but on hold. It has not yet come out. It's still on hold because it's being discussed actively. Lambda leftover, the first one I want to talk to you about is unused parameters ignorance. So when the ability to ignore something you don't need is now being introduced into Java with an underscore. So in this Lambda, I have a by function that takes an integer, a string, and returns a string. So this is the first input, this is the second input, this is the output, right? And I call it BISS because this is a BISS, right? And then I only want the integer value. I don't care about the string value. And here is exactly what I'm doing. An underscore says ignore the second value. And if I have multiple, I can put multiple underscores and they're all ignored, right? Post the underscores, maybe I want the fourth or the fifth value. So I put 3 underscores and then I can access the variable as a fourth element. That's possible. It's an amazing feature. It has not yet been added, but it is something to look forward to. And the return value does convert the string into, the integer into a string. So I can choose which values of an object I want to use and ignore the rest without having to name them. It's a super cool feature. Another proposal is to shadow lambda parameters. This is a bit more complex, but I'll try to explain this. So in the past, if you were to create a map, let us say of string and integer, put some values, seed it yourself, and let's assume you were missing a value. And you do compute some key as your function to add this value, this entry set into your map. If you were to, let's say, compute if absent, key and key to its length, as an example here, today your code will fail. It'll fail because it does not understand the reference to the word key here. However, this is being fixed as a part of the new Lambda proposals, and this is a Lambda leftover that's coming up where this will become possible. There is a JEP for that. The JEP is known as JEP 302. The link is here. Please do read, please do experiment, and you'll know it currently fails, and in the future it will work. The next thing is to better disambiguate Lambda compatibility. A lot of words. So here is an example where I have a method M2 that takes a predicate of string, and therefore it's a Boolean logic. And then another M2 that takes a function of an integer and string and performs some activity with it. I just named the two the same because I ran out of names, or whatever my situation is. Then in a class, I have a static string f that takes a double, a static string f that takes an integer. When I invoke my M2 with a bars : f, the method f, right? The method f in this case will actually result in the predicate being called. It has intelligently figured that out. And that is something being added to Java. It's super cool. So I don't have any code for this. I can't show you code. I wish I had a code demo that I could talk to you about. Anyways, the second to last feature I want to talk about is the Java compiler intrinsics. Amazing feature, not so much for us, but more for the JDK developers, where you know how you write your Java code and it gets compiled into bytecodes. You actually get bytecode instructions such as invoke static, invoke dynamic, invoke virtual, etc. Sometimes what Java generates for you is not the best course of action for the performance you require. Maybe you want it to do something else. And compiler intrinsics actually allow you to determine how you want this particular piece of code compiled and translated into bytecode. So it's super awesome because in some cases you want to slow down the compiler, in some cases you want to speed it up further from what it is, or you want to skip some instructions, and that is possible with compiler intrinsics. It may not help regular programmers so much, but if you are in the library development space or you're a JDK developer, amazing new feature to be added. It's going to change performance by leaps and bounds. However, the caution is intrinsification is a big, big hammer. It should only be reserved when the yields are big, big results, right? So just letting you know. And this from Brian Getz. It's not something I made up. He is the chief language architect for Java, so please do listen to him when he says this. Array patterns was something that existed in the past, but it's currently on hold or sort of being reworked. Array patterns are amazing. Here's an example of what was originally proposed and is no longer possible. It's just like hello, world, and exclamation marks for 3 items in an array. And I could do an instance of on the string array and get S1 and S2 out of it and directly access those. That was array patterns. It is neat. It's super cool. There were further improvements being suggested to this as well, and I'm going to just delve into that real quick. What if you had an array of 10 items and you wanted to get to, let us say, the 7th item in that array? Is that possible? So there was something where you would actually put underscores or just say, a square bracket and say, I need the 7th element. And you could do that. That was possible through the proposal. It's currently on hold, but something to look forward to in the near future. So that was possible. Another deeper example that I would like to share is I have a record point. I have an array of points, And you can actually go dig within or deconstruct the array to get to a specific points, I guess, local or attributes, and use those directly. In this case, I have a point var x1, var y1, var x2, var y2, and I can directly use x1 and y2 out of an array. The deconstruction patterns in Java that are coming out right now are amazing, and I would like you to sort of focus on this. This is the future of Java. Was there a question? I'm on my last slide. So this is something new being introduced, compact method bodies. It's still in draft. I would like you to sort of take this as, this is simplifying your functions or method bodies in Java. So instead of you having a curly brace and a complex statement, single line methods can now be represented with an arrow or an equal to sign. New, but very cool feature being added to Java. So take a look at that. It's interesting. There are different ways of invoking it. For example, in this case, I have a function that uses an arrow-based syntax and a function that uses an equals-based syntax. And there's a subtle difference between the two, right? When I call that method, the this : bar with the arrow actually evaluates to an instance of the functional interface, embodying that particular string bar function. And when you use an equals, it causes an invocation of the function. So an instance versus an invocation is something that happens. This is still being drafted, so a lot will change from what I'm just discussing with you to when it is finally delivered as a JEP, and further when it is delivered as a feature in Java. So your mileage may vary, but this is what we have for today. So that's probably wraps up everything I wanted to share with you today. I thank you for your patience, and if there are any questions, I'm happy to take those.